Okay, this is a short one. I'm getting tired. Gotta have some lunch. But I was just here looking at some of these plates, and they're looking pretty nice. The holes are nice and tight. Good tight holes. We added some 3/8 anchors here just to keep the plates in place while we grouted them. So the plates are getting grouted in with non-shrink grouts. And the gravity plate is on the inside, so it's got 3/8 anchors because nobody cares about its uplift. And then the uplift plate is on the outside, and it's getting these 5/8 wet set anchors. And then all of these are 5/16 plate laser cut that's going to get welded on there and then strap down our CLT. So we're working on this. We're trying to be really accurate. We were having some problems with the other laser we had. It was like a less expensive laser from Amazon, as it were. And then so we got our laser from our excavator. We were using that simultaneously, hashtag all the lasers. So we were double checking with that and running both lasers. And so then I went and got a new laser. So we got a kind of a higher end Topcon laser with the something 100 receiver, the big 4-inch receiver. So it's a RL 200 2S. So it's a dual grade. So it's set to zero on the grade. But yeah, we don't want to have a graded foundation. So we're getting really close. We're kind of, I would say we're inside of a 16th right now. But the sun's out on our boards. So there's some amount of bending that might happen with these boards as the sun heats them and dries them. So we're expecting a little deviation. The variation on the concrete was pretty good. It was sort of all about within a 1/2 inch. So you can see it's kind of like 0 right there. Actually 0 like right there. And then it drops down to about 3/8 there, right here. And then it's up around 1/2 inch here. And then it's back to 0 there. So that's just 30 feet of concrete variation, and we have the same thing going on everywhere. Our high point is here, so these plates are just on the wall, but then over here again they're up 3/8. So I would say the concrete was good to within a 1/2 inch, which is all the concrete contractor promised anyway. And this just comes down to finishing, really, because as they pour the concrete in these forms, they just kind of go down with the laser and dip it in the concrete and say that that's good enough, and then make a bunch of flat spots in it with the laser, and then the guys come along and trowel it. But depending on where they put the flat spot, like if they put the flat spot there, and the guys are troweling and they have excess mud and they don't take it out of the form, kind of end up troweling in a little mountain there. So I'd say all in all, it's pretty good. I'm pretty happy with it. So we've taken our accuracy so far from, plus or minus a quarter to plus or minus a 32nd. And then that accuracy is going to go back down as the sun heats these plates and dries them out. And there's like differential movement and drying. And then we unloaded our glue lambs. So This yellow plastic is our glue lambs. We gotta cover the end here for just in case it rains, but these are our glue lambs. I got 6 of them here. No, 5. 6. 1, 2, 3, 4, 5, 6. We slit the bags on the bottom before we set them. When I pulled them off the truck, I flipped them into the top up orientation. But the catch with that is the bags had water in them. So I didn't want the beams sitting in water. So we slit the bags as we set them down and drain the water out. And then we've got this plastic over it. And hopefully that'll keep them from getting wet again. Because these are finished beams. They're architectural grade finished. They're not getting covered over. And this is our floor framing. So it's 5.5 micro lambs all the way. These are pre-cut to something close to this distance. So we're gonna have a couple of these hanging over. We have some lift slides here. So the lift slides are gonna be thermally broken on top of the foam where the Blued Hero is. And so the micro lambs are gonna come out into the foam to support the door, because there's no concrete or anything underneath of it. So that's kind of where we're at today. Guys got more grout bags and more grout, and we're just gonna keep it going with these plates. It's taking a little longer to put these in than I had. No, actually, I think I had estimated it was going to be hard to do. The total number of wet set bolts is really high. This 2-foot center thing. We've just got like epic amounts of bolts and stuff to dodge. So it's been really slow, but the plates are really tight and the accuracy is really high. So with the CLT panels coming, I expect the accuracy on those to be really high too. So and our square is really tight. We used the Stabila layout station and we set a corner and we shot a perfect 90 degree down here, and we marked our edges here and here, which is the outside of the inside plate. And then once we snapped those, we measured from those, burned 1 inch, and went straight over to that side twice, and then snapped that side, and then we came straight over here 3 times, snapped this side, and then we calculated that diagonal for the dimensions, and then we measured it, and it was perfect in both directions. So the square looks really good. We have another chance to square up a little more on the next layer of framing with these micro lambs. So we're just going to be really careful to make sure we get that laid out really nice. So really like the laser so far. I'm excited to use some of the slope features to shoot a nice plane, like, you know, the septic mound or pipe laying, or checking the feasibility of a driveway location for maximum grade. Anyway, very cool. I'm excited about that. And it was kind of expensive. Like all out the door, it was almost $5,000. But I'm really excited about the accuracy. This is one of the most accurate ones they have, as far as I'm told. Not a laser guru. And its accuracy is measured in arc seconds, which I thought was a fun idea. Apparently you can talk to surveyors about arc seconds and engineers, but construction guys are like, arc seconds, what's that mean? So basically it's a percentage of it's a percentage of a degree. So if you had 360 degrees and then you took 1 degree, the little pie shape of 1 degree, and then you divided that pie shape I don't want to misspeak about how many pieces of a pie shape that is, the arc seconds, but if it was, say, 1,000th of a degree, for instance, that's the shape of the pie. So as you go further away from the origin point, so the laser itself, you go further away, the little pie shape grows. So it's 7 arc seconds, and it's 100 foot from the unit. So in lay speak, as it was explained to me, I'm not a surveyor or an engineer. Let's say that maximum error is a 32nd of an inch at 100 feet, but we're not actually operating at 100 feet. So our tolerance is actually going to be tighter, because if we're only going out 50 feet, you'd expect that to be a 64th. And if you're only going out 25 feet, you could expect it to be 128th of an inch, which is like super, 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 super flat as far as we're concerned. So I'm excited about that. Yeah, I'm going to have to learn more about arc seconds and how to explain that properly and understand it properly. But that's the kind of gross lay speak explanation that I got. And so that's the maximum tolerance, by the way. So they're guaranteeing it within 7 arc seconds, but the machine is designed to try and get closer to, flat. But they're guaranteeing it within 7. So we could actually have a lot tighter tolerance than that. I don't even know where to go from there. Like 1/256th of an inch. It's not really something I'm used to. So I kind of get down to like is it more or less than a 32nd? And then that's kind of where a lot of this type of work stops for me. If I was in the workshop, I'd be looking at things a little closer than that. But yeah, that's where we're at. Super happy about the grading project. It really looks nice, and it's nice to work in a place that's been screened for rocks and you're not tripping and stumbling on rocks all the time. So I might have a little time lapse of these beams getting unloaded. I'll put that up independently, but thanks for looking.